Hello, everyone, and welcome to Nokia in sunny Sunnyvale. My name is Vach Kompella. I head the IP Networks division at Nokia, and I'm going to talk to you a little bit about the concept of what we try to do here. There's going to be a bit of theory, a bit of white space, and then eventually we're going to talk about the real products. But where it started, and this is sort of typical of brainstorming and things like that. Yeah, there's an idea, there's a germinal idea, and then you start from there, and then you water it, and hopefully you get a nice plant out of it. So I'll start with something completely unrelated, but I'll connect the dots later on. So when I started programming, I used an editor called VI on Unix systems. And VI is, if you guys know what VI is, it's a nice line editor. Back in the early 80s, it was the best you could get, right? And as a line editor, it was pretty decent. Even now, VI is a lot better than Notepad. But then I heard of something called Emacs. And now Emacs is very, very different from VI. VI was just a line editor. And so as I worked on programming, I'd open up one window in which I'd have my VI, and I can edit files. Another window in which I ran my compilation, a make or a GCC or whatever. And then a third window in which I ran the program itself. And then maybe a fourth window in which I ran a debugger like GDB. At that time, actually, it was called ADB, but let's use GNU terms from now on. So I had all these windows, and I had all these applications, but they didn't connect. So for example, if I was debugging a program, and there was a function that I was debugging, how do I jump into the code in my editor for that function to look at what's in that function? I don't know. I have to go into my editor. I have to do a search. Maybe I don't even know which file that function is in, and so I'm looking around for it. I'm grepping for it, and it was very hard. With Emacs, you had one application. Inside of that one application, you could open up a window. You could split the window, and you could say, okay, over here I'm going to do my compilation. And you could, have your favorite keyboard shortcut. It could be left elbow, right thumb, to get to the compilation, and you could do that. And then you could run the application in another part of your window, and then you could debug it in a third part. And if you got to that function that you wanted to debug, you could just hit a key, and your editor part of your window would just pop up the function, so you could see it. So it was all integrated, right? You could see the various parts of your entire process of writing code, debugging it, and making sure it was ready. You could even hit a button and check in your code or check out code. So it was all an integrated sort of environment. It made productivity a lot better. So looking at that model, okay, I'm going to assert something right now which is not true of networking, but it should be true of networking. Networking is a program. Okay? Scott doesn't like that, or maybe he's amazed because it was such a brilliant concept. But networking is something that you create, like a text file in which you put some C code or whatever. You edit, you run, you debug, and then you expect certain outcomes out of it, right? So it's a program. It's got input, it's got output, it's got a behavior, and so we want to start with that concept, Okay, now what's missing in networking today? Today, networking is a lot about CLI. So you're going to individual nodes, you're typing in stuff. That's actually the code that you're writing, right? I would claim that when you go to the CLI of any node, a Nokia switch, a Cisco router, whatever it is, and you type in something in CLI, you're actually programming in assembly language. Okay, you're going down to, like, I'm really close to the machine and I'm going to type in something that is very arcane. Nobody knows what it means, and it's like Intel assembly or something like that, and you're programming that language. It's very low level. It's very basic, and there's very little that you can abstract at a higher level when you go down to a node and start typing configuration. You don't know the network behavior when you go to a node and type in there. What you should be doing, and what we do with conventional programming, is you start at a high level. You start with a language like C, C++, Rust, Go, whatever it is your favorite language is, and you start from there, and you don't actually care whether you're going to run on an Intel processor, an AMD processor, an ARM processor, a Cavium, or whatever it is that your down low-level stuff is, right? There's been for the last few years, a concept that we call intent-based networking, where you start with high-level concepts. This hasn't yet percolated the industry well enough. But if you started with high-level concepts like intent-based networking, then you would sort of write a high-level program for your network. You'd say, I want a service, a layer 3 VPN service. How do I get there? I need some constructs. I need some interfaces. They need to have IPv4 or v6 addresses. Maybe they have at sort of the layer 2 level VLANs or not. They have a certain MTU. I need to run an IGP. I need to run maybe BGP. I need to run RSVP. Whatever it is you need. So you're building up the constructs that get you to a layer 3 VPN service. Eventually you get that whole thing. That's sort of like you assemble your program with data structures, with APIs, with functions, and so on, and then you build your program. So your network and the service that you run on it is literally that same construction model, right? So what kind of tools have we given you to do this? If you want to run your network like a program, a top level source of truth, like you have your source tree in programming and a repository where you put your source code in there, people can go in and they modify it at that level. They don't go down at lower levels and touch stuff, because then it's not consistent across the entire developer community that's working on this project. You don't want your network to be something where you've designed all the stuff, and then someone just went into a particular node and changed the MTU, and now things break, and nobody knows where this thing got broken. So you want a top-level source of truth, a repository for your source of truth, and operations that work on that. So I told Bruce and a bunch of other engineers, we're going to lock ourselves in a room, and we're going to talk about programming languages for a network. And because it's 2022, we're going to talk about an integrated development environment for a network. Okay? Like Emacs was, and of course there are much better tools today like VS Code or Eclipse or whatever, but for programming, to improve your productivity, you got these IDEs or integrated development environments. Where is that? It's 2022. It's high time we had an environment in which you could treat the network like a program, and you could build a network and services on it with an IDE, an actual environment in which you had a source of truth, you had sandboxes, you had a way to manage the code and multiple functions that you ran over your network with debuggability, with you know, a CI/CD pipeline environment, all of the stuff that you would really like to have to run your network operations in a safe manner. Well, if that's the concept, then we have to come up with something completely different from what the ecosystem has. Okay, so that's where we started, and we'll talk a little bit about event-driven automation, or EDA or EDA later on. But this is the germ of the idea. Okay, and we started with this. We said we wanted to start with a high-level programming language that we build a compiler for, and it spits out something at a low level that is very specific to that particular hardware, that system. So it'll spit out different instructions if it's running on a Nokia switch versus an Arista switch, right? But at the high level, it's the same construct. It's a layer 3 VPN, it's BGP, it's MPLS, it's whatever it is, interfaces and V4 addresses. At the low level, how you implement it, I don't care. And this engine should know, because we're like, we've been doing this for years and years, and it's basically the same operations we've been doing all this time. Okay, you know, I would like to say that we've got enough protocols. We should be working on operation stuff. As Mike alluded to, we fail to comprehend the value of operations as engineers, and we tend to focus on cool stuff like I got a new protocol. But the operation stuff is absolutely critical. So an operational tool that helps you design your network as a program, manages it just like you do the whole software engineering practice, and gives you digital sandboxes, gives you an environment to play in, so that you can do things like automation, you can design, you can test before you push to prod. Okay, that's really, really important. And as Mike alluded to earlier, if you don't have this right, when you scale this, you break things at scale, right? So we want to make sure that you have the right tool, and this is kind of the starting of the whole idea. I guess the next thing is the actual building this, right? So there's going to be other talks about, okay, we have a concept. We want to do something different from what's out there, but we want the right engine, the right environment in which we can do this. Going back to my Emacs analogy, and all analogies have, you know, their limits. But one of the really cool things about Emacs was the inventors of Emacs didn't know what the next cool thing was that you wanted to integrate into your environment. And so they gave you a programming language. There's a crazy arcane programming language called Lisp. And if you ever tried to write anything in Lisp, good luck. But if you got the hang of Lisp, then you could extend your environment, your programming environment, to cover a new tool. So when Emacs came out, CVS and SCCS and some of these source code repositories didn't exist. And so you could push a button and create a checkout only because you wrote a macro or a little Emacs function to go and do that, something that didn't exist at the time of creation of Emacs, but something that you could add to it. So we wanted not just to create an environment which you could treat your network as a program and have a proper development environment, we want it to be extensible also.
I have a question.
Yes.
Since you brought up one of the great religious debates in Linux, one of the reasons why people prefer VI over Emacs is the fact that it is simple and easy to use, as opposed to becoming an unwieldy operating system masquerading as a text editor. How do you prevent your system from getting out of control a la Emacs and the 98,000 plugins that I have for it?
That's a great question. You will see it in action. There are so many ways in which you can use an IDE. Okay, the problem with VI being too simple is also its advantage, as you rightly mentioned. So when we design something more complex, if you are a novice Emacs user, all you have to know is a handful of keyboard shortcuts. Okay, and keyboard shortcuts is the way, instead of going into sequences where then you put in the function name that you want to call and the arguments and so on, you just have a keyboard shortcut for it, right? And so what we want to do is to give you the tools for you to create elaborate macros and functions and capabilities. But if you're one of the novice users, or you just want to get to where you want to get to really quick, we want to give you very, very accessible tools. So you'll see some cool uses of AI, for example, that allow you to say things that we couldn't do before. But that's just the advances of technology that allow you to then say, how do I leverage one of these new tools to make things simpler for me? So I want to make sure that it's as elaborate as any cool idea you come up with, but I want it to be as simple as somebody who's fairly new to the whole game.
I'm like Mr. Foskett. I am a daily VI user, and the reason that I use it all the time is because it's the lowest common denominator. It's everywhere. Emacs is great for the developer that has their one machine set up perfectly for them. But me, I'm logging into a million different Linux boxes, routers, switches, whatever. VI is the thing that I can rely on to be there everywhere. And yeah, it's not as powerful, whatever, but it's there. And so I need to know how to use it, and it gives me a minimum set of capabilities. One of the things I think about with the network stuff is that we can be constrained by that lowest common denominator in our network. We can say, all right, I've got this great tooling, which is going to do all these wonderful things, but in the middle of my network, I've got this CatOS box. I personally don't, just to be clear, but people do. And that's sort of one of the challenges I think that's going to be there for you. I think is that how do we deal with that lowest common denominator? How do we make sure that when I'm trying to do something at a high level, it says, hey, actually, no, you can't do that. Well, the thing you're trying to do is not going to work as long as you've still got this 10-year-old box here. Everyone sitting in network vendor land is like, oh, we've just, we've released this new code last week and we just put it in all our boxes and we're just running that. Don't you all have those things? Well, no, we don't, because upgrading everything is time consuming and hard, and we don't have all of those capabilities. So hopefully we'll find out a bit more today about how you think about that piece of it. Because, let's face it, we're not all going to be running all Nokia networks. We're going to have a variety of things out there. So sure. How that fits together is a bit that I'm interested in.
So you pushed my VI Emacs analogy to the limit, and you also brought in brownfield.
I don't want to go too far down there. That lowest common denominator, I think.
Between brownfield and pushing my analogy, that was a low blow. But Lindsay, I'll take this and just say, when you see EDA and the user interface, you'll get to see a side of it that is very easy to use. So it's sort of like VI. You could just, it's fairly straightforward. You can go deep into JSON and stuff like that. That's all the works behind it, right? But we don't need to necessarily have everyone dive into that. So that's the whole point of us trying to make it as flexible and powerful as possible, so that you can cover all the use cases, but then just give a bunch of canned use cases that you just have to push a button to get to, right? Brownfield is actually a hard problem, and we'll come to that also. But certainly multi-vendor has to be part of our solution. If we don't have multi-vendor, you're dead in the water. Especially us as Nokia being new to the game. Rita?
I work with enterprise level data center network customers every day. And the majority do not have anyone who knows automation on staff. So they're always looking for simple solutions with a lot of visibility. So that's why we're seeing more and more controller-based systems or orchestration-based systems where configuration is kind of step-by-step. They're no longer going to the command line. And I'm seeing that a lot in the enterprise space. Now, in the upper enterprise space, yes, we're seeing people with automation on staff. What you're talking about so far, I think might be a little bit intimidating to those who do not have automation teams.
Well, you don't have to use, like I said, you don't have to use automation from the get-go. The first thing you want to do, like when you write a program, the first thing you want to do is be able to address the configuration that you want to deal with, okay? The second thing you want to do and deal with is deploying that. And then the third thing is you want to monitor the state. All the other stuff that you want to do after that, complex automation workflows and stuff like that, is a future sort of aspect of what you can do. But you have to have these bases covered, but you can't have 16 different tools that you can't integrate into one consistent view of the network, whether it's configuration management, it's telemetry, it's faults and alarms, but then it's the workflows, it's the inventory of your network, it's what's happening across the whole the ecosystem of nodes that you have. So we wanted to make sure that the tool is both covers all these bases, but it's extensible. So as you come up with new ideas, you don't now devolve into, oh yeah, this was great for this, but I've got another tool. And once you have the other tool and you can integrate it in, okay, then you're coming back to today's situation that Mike talked about, 231 different applications that you don't know how to, which one is going to be the best one, and you don't even know how to connect all of them together. So that's,
I'd like
Scott.
to build on Rita's comments a little bit and maybe take it a little further. The idea of ID for the network is a framing thought for this. Like, I've never heard it put that way. That's really interesting. Let's see how that plays out today. But this isn't where you started with the IP division, right? You have years of dealing with CSPs, and you know there are lots of trad net-eng folks out there that are intentionally, I'm not a programmer, and I don't want to learn how to do automation. You said you want to make all these tools accessible and you want to make it useful to all types. How do you address that audience that here's ID for the network and goes into apoplectic shock?
The concept of an IDE for the network is for those who want to build on top of the basic stuff, right? So when we talk to partners, for example, the value add they bring is, look, I've got 5 vendors out there that are giving me data center switches that I can put in, and I'm going to configure a standard EVPN with VXLAN. Everyone supports it. So what's different? Well, they want to bring in some value add. They want to bring in their ability to manage this network better or deploy services in a certain way. And so the value add that they bring could be that they integrated it in with ServiceNow. Okay. And now if you didn't make it easy for them to put that in there, they would be tied up in knots trying to figure out how to make this network generate events into ServiceNow. Sure. So not everyone is going to need all the capabilities, but there are people, whether it's Nokia Professional Services, whether it's our partners services organization, they're going to need these tools. So that's the whole concept, is we're empowering a certain set of people who need the tools to make sure that their ecosystem grows appropriately, but the tools don't get obsolete. I got to stop.